Hey everyone, so I just want to go over how to write the equation of a line in both slope-intercept form as well as point-slope form. And later on in the video, we're also going to look at how to graph a line and how to graph an inequality. So first, on the left-hand side, you're going to see that the slope formula equals y2 minus y1 over x2 minus x1, where x1 and y1 are just 1 point, x2 and y2 is the second point. Slope-intercept form is y equals mx plus b, where m is the slope and b is your y-intercept. And then again, point-slope form, y minus y1 equals m multiplied by x minus x1, where x1 and y1 are points that lie on that line, and m is the slope of that line. So in class, we looked at number 5, which was write the equation of a line who contains the points -6, 5 and has a slope of 1/6. Be sure to express your answer in point-slope form. So now the state has given you the equation for point-slope form on the reference sheet. So because it says point-slope form, we are going to write down y minus y1 equals m times x minus x1. Now for here, we have y, our y coordinate is 5, so minus 5 equals m is our slope, 1/6, multiplied by x minus, and then our x coordinate that's given to us is -6. Now we just don't really like to write a double negative, so we're going to rewrite that as y minus 5 equals 1/6 multiplied by x plus 6. And just a reminder, the x and the y of that coordinate that's seen is kind of opposite of what's given to you here. For number 6, it says write the equation of a line who contains the points of 1,7 and 4,22. Express your answer again in point-slope form. So for this problem, it's slightly different than the one that we just looked at because we need to do a little bit of work. We have a point, they gave us 2 actually, but we still need a slope. So in order to find the slope, we're going to use the slope formula, which is y2 minus y1 over x2 minus x1. So I'm just going to start with the second y coordinate that's given, subtract the first over 4 minus 1. Now when I type that in the calculator, you're going to get 5. Now I know that m is 5, and I'm just going to pick either the first or the second point. I'm just choosing this first one. So the point that I'm going to use is 1,7. So I have a point, I have a slope, I can plug it right into the formula now. So y minus y1 equals m multiplied by x minus x1. Y minus the y coordinate, which is 7, equals the slope of 5 multiplied by x minus the x coordinate, which is 1. Oops. Let's look at number 7. So 7 says state the equation of a line that passes through the following 2 points, -3, 8 and -6, 5. But for this one, instead of point-slope form, they want us to write it in slope-intercept form. So slope-intercept form is y equals mx plus b. Now you could use what you did in 7th grade and how we kind of started off the unit of doing it the long way, where you plug those 2 points into the slope formula, get that slope, and then pick either the first or the second point, plug it into y equals mx plus b, as long as with the slope that you just found, in order to find the b, and then you'd have your m and your b. But like I said in class, I do want you practicing with the calculator because of that stats unit. So because I see that it's in slope-intercept form, I could use L1 and L2, where L1 is your x values. So -3 and -6, and your L2 is your corresponding y value. So when x is -3, the y value is 8. When x is -6, the y value is 5. So once I have my 2 points, I'm going to the calculator. I'm going to hit stat, edit. In L1, I'm typing in those x values of -3, enter, -6, enter. Then I'm going to the right-hand side and typing in those y values. So when x is -3, we said it was 8. When x is -6, it's 5. Now that I inputted all those values into the calculator, I'm going to hit stat again. And now I need it to calculate something for me. And what I want it to calculate is a line. So I'm going to hit option 4, or you could scroll down to 4. You're going to hit enter until you get to calculate. And then your calculator is going to give you these A and B values, which A is your slope and B is your y-intercept. So for your work, you're going to write down y equals ax plus b, exactly what you see in the calculator. A is 1 and it said b is 11. Now that I have those values, I'm going to plug in 1 where I see an A, and I'm plugging in 11 where I see a B. So the final equation of this line is y equals 1x plus 11. But again, like I said in class, you're not really going to see that coefficient of 1. So y equals x plus 11. Okay. So number 10, we looked at, it says determine the equation of a line that has a slope of -2 and contains the points 5, 2, and be sure to express your answer in point slope form. So I see point slope form. I'm going to use y minus y1 equals m multiplied by x minus x1. I have an m of -2. I have a point of 5, 2. So I'm going to plug the points into the x1 and y1 and the slope into m. So y minus the y coordinate equals the slope of -2 multiplied by x minus the x coordinate of that point. So that's it for the first part. And then the second part says take that answer in blue, which is point slope form, and now convert it into slope intercept form. So basically what you're doing is just solving for y. So I'm going to rewrite that equation. And when I use distribution to solve for y, I'm going to get a final answer that looks like y equals mx plus b. So I'm going to distribute out -2x plus 10. I'm adding over the 2. Y equals -2x plus 12. Now you can check to see if it's correct in the calculator using that y equals button. Whenever you have an equation, we hit y equals. And I'm going to type in my slope intercept form. So the one in purple, -2x plus 12. Now to check if it matches the one in blue that we started off with right here, the first thing that you would have to do is just make sure that the y is by itself, because if you look at the calculator right here, everything is in terms of y. So in order to get rid of this right here, this -2, you're going to you're going to add that over to the other side so that y is by itself. So when I add that -2 over, we have y equals -2 multiplied by x minus 5 plus that 2 from the other side that we added over. Now if I hit second graph, you'll notice that everything in y1, which was my slope intercept form, matches everything in y2, which is that point slope formula, which just confirms that both equations are the same even though they look slightly different. So point slope form and slope intercept form still is the same equation containing all the same points, it's just looking different. Now here, if we had to determine the equation of a line in point slope form, we need a slope and a y-intercept. Sorry, I think I said point slope form. We're just going to do slope intercept form first for this part. So for here, my m is how I'm moving from one point to the other. It is my slope. My b value is the y-intercept, and the y-intercept is where the line is crossing the y-axis, where it intersects the y-axis. So that is the point 0, -4. Your b value is -4. Now for your slope, you're figuring out how it moves from the red point to the blue point, from left to right as I scan across. So I'm going up 1, 2, over 1, 2, 3. So your slope is 2/3. Your y-intercept is -4. So the equation of that line in slope-intercept form is y equals 2/3 x minus 4. Now for the follow-up, it does say point slope form. So for point slope form, you need a point and a slope. So we already have that m value, which is 2/3. I am just going to use this point right here because it was already circled for us and bolded in. So that's the point 3, -2. So once I have my point and my slope, I am just going to plug it into the point slope formula. So I'm going to do y minus my y coordinate. So y minus a -2 is a +2 equals my slope m multiplied by x minus my x coordinate. Again, for this one, the answers can vary, but I'm just going based off the point 3, -2. And for this one, we're going to graph the line -3x plus 4y equals 24. But before you start graphing that line, you do need it in the correct slope-intercept form. So you're going to add over that 3x. Oops. 4y equals 3x plus 24. Then lastly, get rid of the 4 by dividing. And you have y equals 3 over 4 x, and then 24 divided by 4 is 6. So once I have that line, I am going to start with the y-intercept, which is +6, 1, 2, 3, 4, 5, 6. And my slope tells me how to move. So it's saying go up 3, right 4. So up 1, 2, 3, 1, 2, 3, 4. I can't go any further in that direction, so I'm moving backwards from that purple dot. So 1, 2, 3, 1, 2, 3, 4, 1, 2, 3, 1, 2, 3, 4. Again, I can't go any further. You want a straight line with arrows on both sides, connecting all our points. And then the follow-up question is saying, is 4, 9 a solution? Justify algebraically. So because it said algebraically, I need to plug 9 into my equation to see if the left-hand side equals the right-hand side. So I'm going to start with the original. -3 multiplied by 4 plus 4 multiplied by the y-coordinate, which is 9, equals 24. Now when I type the left-hand side into my calculator all at once, or if I do it piece by piece, I have -12 plus 36, which is 24. And 24 does equal 24. So this is my justification algebraically. My answer is yes or no. Because it doesn't make a true statement, the answer is yes. Now, if it didn't specifically say justify algebraically, what you could do is visually check. So all solutions are points that lie on that line. So if I went over 1, 2, 3, 4, up 9, I would see right here that the point 4, 9 does lie on the line, which means it is a solution. And the last one that we're going to go over is number 15. You'll notice that the work is there already for you because the time is going to run out in 1 minute. So real quickly, you do want to rearrange it so that it's in slope-intercept form. You'll notice in green, I did flip the inequality symbol because I'm dividing by a negative coefficient. That symbol tells us two things. It tells us the type of line and the shading. Because it's an or equal to symbol, we are going to connect the dots with a solid line, arrows on both sides, and the symbol is telling us it is less than, so we are shading in the downwards direction from that line. And then it says, is 2, 0 a solution? When I look at 2, 0, it does lie right there. And my answer would be no, because it's not in the shaded region. And I'm just going to stop writing because it's going to cut me off. Thanks. Bye.